It is indeed bright and breezy.
Fantastic. Well, welcome everybody. Welcome to another Reading Online Sport Economics seminar. We are, as has been quite often, which is nice. We are welcoming Stefan Szymanski to give a talk today. He was on a few weeks ago when he was going to talk about the paper that is titled for today, "Enduring Love: The Long-Term Effect of a New Stadium on Attendance at Professional English Soccer or Football." But then the European Super League got in the way a couple of months ago now, and so Stefan presented on the European Super League back then. We're delighted that with a gap in the schedule, we were able to have Stefan to present that work that he was originally going to present, which is joint with Gideon Janka. Stefan, please do take away your talk.
Thank you, James. Let me see. And can you see my slides now?
Can indeed.
Very fine, very fine. Right, well, thank you for giving me the chance to catch up and give this paper eventually. And as you say, it's a joint work with Gideon Janka, and I've a slightly different title from the one I gave, but it's the same. It's the same story. I'm just experimenting with ways of presenting this. And this is if you want to know how much work has gone into this paper and how hard this has been, Gideon has managed, in the time since we started writing this paper, he's managed to complete not one but 2 PhDs, and we still haven't finished the paper. So which I think is pretty impressive. So if you could get the backstory of that from Dr. Janka at some point. But he, on the back of that, he's now moving from Michigan to take up a faculty position at the University of Florida, which is all very fine, which maybe will help us finish this paper too. All right, so let me start off by just telling you the basic story here that I'm going to present today. I'll start off with the picture. So that's a picture of New York Stadium, which is rather fine, which is in the town of Rotherham, a town in the north of England with a population of about 100,000 people. Their football club has been in the English league system since 1926, which makes them a relative newcomer for English football, although they are a successor to, they were a merger of 2 clubs that existed in the town before, so you could argue it both ways. They've never been in the Premier League in the top division in their entire history. They did come close to the early 50s. And this stadium was built in 2012, and it has a capacity of 12,000 people and cost £20 million to build. So in many of the aspects of that story signal a significant difference between the nature of stadium, the context of new stadium building in the United States and in England and in the world of soccer, football in general. And that's what we're really focusing on in this paper. So when you build a new stadium, you are creating a new environment for your fans, and so there is going to be a treatment effect. You're treating the fans in some way differently than you treated them before, and there is a substantial US literature on this treatment effect, if you will, on attendance at stadiums, and that literature has a very powerful consensus that this effect tends to wear off over time. There's very little ever been written about this kind of effect in the world of football, and certainly in English football. And what we've done in this study is looked at the impact of new stadiums in England. And we find a treatment effect which is persistent. It doesn't tend to evaporate over time. It seems to last. And in particular lasts at least as long as any of the time periods covered by the US literature, which finds that it disappeared. So the sort of the really interesting question then, I think, is what is the difference? Why should it be persistent in England and disappear in the United States? And you could just say, oh well, England and the US, they're just different places, different sports, different context, different culture, and that might be one way of looking at it. But our view is that there's more to say than this. The treatment effect of building a new stadium has to be taken in the context of that environment in which it's happening. And there is the big difference, I think most of the sports literature acknowledges these days, the big difference between the sporting environments is the existence of the promotion and relegation system in the world of football. And that's where we identify the difference coming from. In England, when teams build new stadiums, they're much more likely to get promoted to a higher division, something that won't happen in a closed league. And when teams get promoted to higher divisions in England, they see, and in pretty much anywhere in this where that has this system, we observe higher attendance levels. And that, in our view, is what is sustaining this treatment effect in the new stadiums. And what I'm going to do in the rest of this paper then is try to persuade you of that, looking at the data for new stadium construction in England. So first, let's talk about the US literature, which tends to go under the name of the honeymoon effect, hence the rather lame joke that we were attempting with our original title, Enduring Love. So what we're saying is it's not a honeymoon effect. I mean, it's not that things wear off after the honeymoon, and it's actually something that tends to last. So here's most of the literature that we could find on this effect. There's been a number of papers written. Some of these papers, such as Coates and Humphreys in 2005, look at several different leagues in the same paper, but you can see here there's a number of different papers. These are all North American leagues, apart from the Feddersen et al. Paper, which looked at the Bundesliga, although that paper didn't really look at effects over time. So what we did was to think about what the honeymoon effect looks like in the literature. We looked at the coefficients reported in the regressions and tried to figure out what they said about attendance over time. And so we came up with this table here, which shows the age of the facility and the percentage impact on attendance. And you can see here that most of these papers look really only about 10 years out. Some of them look a little bit further out. But over the 10 years, the pattern here that you can see is incredibly consistent of an attendance effect that is quite large in the first year, and then which tends to dissipate quite rapidly. And by year 10, it's really pretty small. And when we look at the papers that go out further, then it's pretty much vanished by 15 years out. And what you can see, the last column there, we've just taken a simple average of these percentages, and you can see here what that looks like. That's the existing literature. So let's think about new stadiums in England. So first, a bit of background about this story, and I think some people often may be surprised, certainly people of my age associate England with not having many new stadiums and it not being really a thing, but actually it's been quite a big thing over the last 30 years. And the history of this really is, again, if you're familiar with this, with football, you'll know about this. If not, this may be a useful background. The Football League system in England consists of 92 teams organised in 4 divisions. That's been true pretty much since 1923. So it's a very long-lasting and very stable system. And if you look at the ages of stadiums, but if you go back to 1988, so 33 years ago, then the newest stadium in English football in 1988 was already 36 years old. And not only that, but all but 3 of the stadiums that teams played in were more than 50 years old. and more than 3/4 of them had been built before 1914. So in 1988, what we were talking about was, if you like, a capital stock that was pretty ancient. And it's perhaps in hindsight, it's really not surprising that this was associated with quite a number of disasters. There's really a tragic history of stadium disasters in England. Not just in England, this has been a problem around the world, but the three sort of famous ones in the English context, and these are by no means the entirety of it. There are more minor incidents that happened that are associated with decrepit stadiums, but the famous, the biggest ones, I suppose, are the Burnham Park disaster in 1946, 33 people crushed to death. The Valley Parade disaster in 1985, 56 people burnt to death in a stadium, and then of course the biggest of them all, the Hillsborough Stadium disaster in 1989, where 96 fans are crushed to death. And really, we could talk about the various factors which contributed to this, but the obvious common theme amongst all of them is that these were decrepit, out-of-date facilities that did not have even basic safety standards. And that led to the government intervened after 1980, after the Hillsborough Stadium disaster. The government intervened and mandated all-seater stadiums in the top two divisions, and required significant wholesale changes. And this coincided with a dramatic recovery in English football in general, and certainly a recovery in attendance and a recovery of interest, and it's associated with a significant amount of investment. So based on the financial statements of the clubs, you can identify over £2.5 billion worth of investment in tangible fixed assets since Hillsborough, and that £2.5 billion is almost all of that is stadium related expenditure. So there's been wholesale renovation and improvements in stadiums. And so this is the period that we're going to study in this paper, really, this period from 1990 onwards. So this is set about against a background where almost every team that plays in the league system is investing to some extent in upgrading their facilities. But that's not the same as building a completely new stadium, and that we're interested here specifically in the new stadiums that were built. So here's a list of the new stadiums. So between 1988 and 2012, you have 31 new stadiums. Between 1988 and 2012, you have 31 new stadiums built. And of course, actually, since then, there's more going on. People are probably familiar with some of the bigger ones, obviously Tottenham, West Ham moving into the Olympic Stadium in London. So it's by no means over, this process. And what you can see here is an immense variety of experience. So it's not just teams in the top of the system. In fact, only 6 of the stadiums in our data set were built for teams playing in the top division at the date when the stadium was opened. There have been a number of new stadiums built at the lower levels, including 2 here, the teams that were actually not even in the 4-division structure at the time. They were playing at the 5th level and were subsequently promoted to join the Football League system. And you can see a huge variety of capacity. So the stadiums in this list range between 6,000 and 60,000 capacity, and a huge range in cost between £7 million and £538 million. So there's really a tremendous variety here. There is also actually an interesting question about the financing. Of course, in the US, the big issue is always the extent to which public money is used to subsidize the construction of new stadiums. There's quite a bit of public money kicking around in these stadiums here and there, although many of them are actually private investments. Most of the money is actually private money, but there has been a percentage that has come from the public sector. So with that background, let me show you some, talk about the data and provide you with some descriptive statistics for the data. Okay, so what we're going to do is look at, we're going to, in order to estimate treatment effects of building a new stadium, we're going to look at this at the game level. So we have a data set of all games played in the top 4 tiers of English football between the 89-90 season and the 2015-16 season. So that's nearly 55,000 observations in total. And obviously our variable of interest is going to be match attendance. So we're going to think about a number of other covariates that we're going to be interested in. So you'll not be surprised if you're familiar with my work that wage spending is going to be part of this. So we're going to approximate the quality of the home team by the annual wage spend of the team. We're also going to include the wage spend of the away team as well as the product of home and away team annual wage spending, which is intended to capture in some sense the match quality, the quality of the game. Another covariate that we're going to be interested in is that we're going to work with is surprise. And so the surprise variable measures the difference between the expected outcome and the actual outcomes of matches played up until that point in the season. And a number of papers have shown this to be quite a significant determinant of attendance at games. Normally one uses bookmaker odds data to calculate the surprise. However, the bookmaker data doesn't go back to 1990. So what we did was develop a model where we modeled the bookmaker odds based on historical performance and fitted that and got a good fit for the betting odds for the years where it is available. And then we use this measure of expected outcome to measure surprise across our entire data period. Of course, the performance of the teams in the leagues is something that we're going to be interested in, and in particular, we're going to look at the promotion and relegation effects within the data. So we've got the performance within the league. And then the other benefit of working at the game level is we can capture day of week effects, holiday effects, and also point in the season, week of the season effects, and these are all very important. Of course, as a social activity, people follow football based. There are certain patterns that they're following which fit in with their lifestyle, and these can be captured using game level data. For example, so obviously, for example, on holidays, you tend to get a significant boost in attendance. Okay, so let me just, here is just a simple summary chart of the basic finding in the data. So the way this is constructed is we have a profile of attendance for each team, which has a new stadium. We know the attendance before the stadium is built and the stadium and the attendance after the stadium is built. So what we've constructed here is an index, and we've indexed each team to the first year in which the stadium was open, the first year in which games were played in the stadium, relative to the average in that season for teams playing in the same division as that team. So clearly the issue is, what are you comparing these teams to? What is the benchmark of what standard should we adopt? So we chose to adopt the standard of the other teams in the same division that you were playing in this season in which you first played games in your new stadiums. And this average, so here is an average of that index for each of the teams in our data set. And so we have you can see a very clear story in here. So the average index for teams in the 6 seasons leading up to the opening of the new stadium, the average value of that index is 73. And the average value of that index over the next 14 years after the stadium opens is 110. So that's roughly a 50% increase relative to the teams that were playing in the same division at the time that the stadium opened. And obviously, what's also clear is that this seems to be a pretty stable trend over time. You can see very clearly the step jump from time 0, which is the season before the stadium opens, and time 1, and then you can see, if anything, a little bit of a boost in the following 1 or 2 seasons, and then a relatively flat trend over for the remaining period, and no sign of any decrease that we observe that we find in the US literature. Now,
Stefan,
what I'm going to do now is actually go through look at some of the individual teams and try to classify them. So you might be suspicious of just a simple average like this. So you probably want to see what this looks like on a team by team basis. And so let me show you some charts of the individual teams. And remember, these are all just averages at the moment based on this index. So here I've defined what I call type 1 teams, where we observe clearly a step increase from time 0 to time 1, and what I would say is, broadly speaking, no obvious trend afterwards, or a stable trend after the event. And perhaps the easiest ones to see this are actually, if you look at Arsenal over here on the right hand side. Arsenal built the Emirates, opened the Emirates in 2006. And you see a step up, and you see a stable progress afterwards. Of course, Arsenal playing in the Premier League were largely playing to capacity both before and after. And to the extent that there's any variation in this line, it's actually related to the other teams in the division. Arsenal's attendance is almost completely invariant from season to season. It's just the composition, the Premier League composition effect, which is causing any variation here. Or Manchester City.
Stefan, just to interrupt you, Alex asks if the index is based on the attendance or just due to the capacity of the stadium.
I'm going to come on to the capacity issue later, because obviously in the case of Arsenal, you're going to be concerned about that. And the same thing is going to be true about Manchester City as well. So Manchester City, you can see the same trend, but you're obviously going to be concerned about the fact that most of these games are being played to capacity. But if you look at these other cases, you look at Derby County, Huddersfield Town, Rotherham, Brighton. These are cases where the capacity issue is not likely to be significant. In fact, for most clubs, at most times, capacity constraints in the Football League are actually, we find in the data, are not significant. But I'll come back to that in a little bit. So here's what I describe as type 2, where you see a step increase from time 0 to time 1, and then you see a trend increase afterwards. And you can see here, Reading, Swansea, you see significant increases. Sometimes this trend goes into reverse. So Hull, the trend continues upward for a number of years and then actually goes into reverse. The same looks to be coming the case for Wigan Athletic, and again Sunderland as more of a roller coaster. But there is the point here is in these type 2, you are seeing some continued increase after in the post opening year seasons. Then here's type 3, and actually here in these cases we see something like a trend decrease. We see a step up at opening, but we see some decline over time. So again, Middlesbrough sort of step up, sustained for a few seasons, and then actually sort of tending to decline. I've drawn vertical and horizontal lines around time 1 and the index value of 100, so you can see, roughly speaking, whether you're above the horizontal line or below the horizontal line tells you roughly where you are relative to the teams we're comparing you to. And so you can see a number of broadly negative experiences here, though, again, in these particular cases. And then here are sort of four potential anomalous cases where actually we see a step down at the time of opening of the stadium. And all of these three of these have a fairly straightforward explanation. So Bolton played their first game in their new stadium on September 1st, 1997, a season in which they'd been promoted to the Premier League. They just arrived in the Premier League, but they had a disastrous season and they were relegated at the end of the season. And that might seem to be why they actually saw a decline in attendance. In the season they were getting promoted, they had a lot of enthusiasm. In the season in their first season in the new stadium, that enthusiasm must have waned quite rapidly. Almost exactly the same story for Stoke City. In fact, Stoke City almost exactly the same dates as well. First game in August 30th, 1997. They were in the second tier in the previous season and then were relegated to the third tier at the end of the 97-98 season. So again, a story of decline, presumably associated with dreadful performance of the team and ultimate relegation. Colchester in 2008, it wasn't so much that they had a bad season after opening. It was that in the season where they opened the stadium, first game on August the 4th, 2008, they'd actually just been relegated the previous season. And so notwithstanding a shiny new stadium, a lot of fans were less interested because they had been relegated. So those three stories seem to have a very simple explanation. The one I really can't explain is Millwall on August 4th, 1993. They were then in the second tier. They actually had quite a good season and they were in contention for promotion to the Premier League, but they didn't make it. And they did see an increase in attendance. Attendance at Millwall in that season rose by 6.6%. It's just that attendance rose even faster in the rest of the division. It rose by 11.1%. So that may be a composition effect. It may have been having a particularly strong team that was playing in that division in the year. But there was nothing particular about Millwall. I looked to see were there big hooliganism problems in that season or any other significant problems, and I couldn't find anything that suggested any significant problems. It's just an anomalous case. Now, there are some cases I haven't covered here, where I haven't shown you a chart. So there are 4 clubs in our data set which opened just about the time of our first observation. So we don't really have any pre-treatment observations, or very few, and so we haven't included those. There are 2 clubs that were non-league teams at the time, as I mentioned, Crawley Town and Morecambe. When they built their new stadiums, they actually entered the league later, but we don't have the attendance data for them in their non-league incarnation. MK Dons, anybody who, those who follow English football will know the long and complicated story of MK Dons. It's still one of the most controversial stories in English football. Suffice to say, when they relocated, the relocation is still considered a gross crime, and they are still widely hated for this fact of being a relocated team. They relocated from Wimbledon, which geographically is only about 50 miles away, but that's a whole continent as far as football is concerned. They also got a new stadium in 2007, but this is also tied up with the weird and strange story of the relocation that we decided that was one we should drop. And then Oxford United is one where we have a significant interruption in our data because they actually they were relegated to the 5th tier 4 seasons after the opening of the new stadium, so we don't have any observations. So that covers the 31 stadium cases in our data set. So here's our estimation strategy. We're using a difference in difference approach. The treated clubs are the ones that get the new stadium. So in the canonical model, you have this average treatment effect of the treated, where you compare the average. So compare the average values after conditional on being treated to the average values before. In the canonical model, there's just a before and after, but of course, in our case, we have time varying treatment effects. So we can estimate. So we can do a simple before and after estimate to see what the value is. We could break it down into periods. So we could take, say, 5-year periods, and then we could just look at individual year effects. And in our estimation, we do all three. So of course, everybody was well aware that there's going to be issues about heterogeneity and selection bias in our data. So we hope that our covariates are going to control for known sources of heterogeneity. So the sorts of things that I talked about before in our covariates, we can capture a number of those factors. We're going to use the two-way fixed effects estimation for unobserved heterogeneity. And in this, we're going to allowing for the fact that we can think of the divisions as being really separate organizations. In some sense, we can actually have have season division dummies included. So we can capture different seasonal trends according to divisions. And then I'm going to go over a number of robustness tests that we applied to look at the data as well, once I've shown you the results. Okay, so here are the basic results for our data, basic regression. So there are 4 models here based on these 3 elements. So whether we include the covariates, whether we have the season tier interactions, and whether we have the club effects. And so these are just, so probably best to compare model 1 with model 4. Model 1 just includes, is just the treatment effect on its own, and model 4 includes all 3, the covariates, the season tier interactions, and the club effects. And so here you can see the 2 versions. Here's the A refers to the single treatment effect, so just a single post-treatment coefficient. And here we have groups based on the number of periods before and the number of periods after, so 5-year intervals, 5-season intervals. And the bold horizontal line is the division between before and after. And what you can see here is that in model 1, you can see a very clear treatment effect if we just consider the post variable on its own. And when we look at the groups, we can see a significant difference between the before and the after. And what we can also see is there's no tendency here for this value to decrease. It seems pretty. There's no evidence of this honeymoon effect dissipating over time. If we include, though, all of the covariates and all of the other all of the fixed effects, then, well, firstly, to notice here, just look at the bottom here, you can see the R squared goes up from 0.03 to 0.93. So clearly, you need to. It's essential to include all of these things because they do make a significant difference. You'll notice that the number of observations falls from the 55,000 I was talking about at the beginning to about 32,000, and that's because of the wages being one of our covariates here. And we don't have annual wage values from the financial statements for every season, for every club. So this becomes a more restricted sample. But again, you can see here in terms of the story in terms of relative to the treatment effect. If we just have the single treatment effect, we can see a very significant value here. And if we consider the group, the period effects, then we can see here a step, again, a significant step from the before to the after. Maybe some slight evidence of a decline here, at least from the first 5 years to the second 5 years. But then again, when we go from the second 5 years to the third 5 years, it looks pretty much the same. So there's not this tendency for the effect to disappear 10 to 15 years out. So let's now look at, so here you can see the entire profile again. So this is the same setup, it's just the individual year effects. I don't know how depending on how good your screen is, you can see this or not see this, but I'll show you a picture in a moment. But it's a pretty simple story. There is a clear step between t0 and t+1, and there is no sign that this vanishes over time. The difference between t plus anything and t minus anything is always very large. And that's true in model 1, where we have none of the other covariates, and it's true when we have model 4, when we have thrown the kitchen sink at it. It's all there, and you can see the step jump. So let's look at some charts here again. So just a nice simple summary of this, model 1 and model 4. So model 1 with no other covariates, again, it's a bit all over the place, and you can see lots of things going on. And as you should expect, when you have model 4, you've included all of the other covariates. You get a much more what we should think of as probably more reliable set of estimates, and we see a very clear step at t0, and no evidence that this disappears at all. It just remains pretty flat thereafter. So let me talk a little bit about some robustness tests then for this. So we thought about a number of ways in which we could check to make sure that these we really are capturing the treatment effects here. So in this difference in difference literature, one of the things people usually do is to talk about parallel trends, and there are formal tests for parallel trends are well, there are some out there claim, but generally speaking, it's argued that it's hard to test for parallel trends, and that there's just a visual check. Is it the case that the treated and the control groups were on the same path prior to the treatment? And for that, one wants to see that the pre-treatment there is no trend difference in the performance of the time dummy estimates. And you can see in model 4 here, our time dummy estimates are pretty flat, suggesting that there's no real trend differentiating them from the control group prior to the treatment. One of the tests that's suggested in the literature for dealing with this is to think about adding a unit specific time trend. So if we add a time trend, we should we should still see the same treatment effect estimates. We should see the same step, and indeed when we include a unit specific time trend, that's exactly what we find. So it's robust to that specification. So when you think about selection bias, often one of the problems with selection bias, you often don't know anything very much about the entities before your data period. Well, in this case, of course, we do know quite a lot about these clubs, and we have a lot of financial data and performance data about teams before the whole process of building stadium starts. So here's a logit regression that we ran for 85 of the clubs in the 1985-86 season, so before any of these stadiums were built. And we looked at this to see whether there were any significant differeces between those which would end up being treated and those which were not treated. So the sorts of variables here is, you might think there'd be differences in terms of the status of the teams, in terms of maybe some were higher up the divisions or lower up the divisions. Maybe some had higher attendance or lower attendance. And we didn't find any significance there. Looking at financial variables, there was no difference in the measure of profitability. There was no difference in the measure of fixed assets. There was no difference in the measure of net debt. There was no difference in whether they had positive net assets, which is a measure of financial health or solvency. The only difference was the revenue per fan, which was significantly lower in those teams that built a new stadium. Now that's actually, you wouldn't think of that as being a terribly good signal. if you're always going to ask you if you're going to put up your own money to invest in building a new stadium for a team which generates low revenues for each fan that it accepts, you might be slightly worried about this. So you say, well, you know, if we're below average already, how is that? You know, aren't we just throwing good money after bad? So if to the extent that that's significant, it would not seem to be necessarily a good indicator of the likelihood of, it wouldn't be a positive indicator for building a new stadium. So we looked at, this is based on the logit, you can estimate the probability that each of the teams would build a new stadium, and of the 24 clubs for which went on to build a stadium, only 8 of those clubs did we have an estimate that they would build a probability of building a stadium of more than 50%. So in effect, this data is suggesting that there's not an obvious selection bias that you can identify looking at the nature of these clubs just before this era begins. So there's a recent paper by Callaway and Santana which looks at differences over multiple time periods, and because of course it is a problem with the data that we have